Now let's continue solving literal equations. Here's your first one. See how you do. Since t is our variable of interest, then by order of operations, if t was a number, we would square first, multiply by g second, and then multiply by a half third. So here's my two-column table. Please notice that the inverse for multiplying by a half is multiplying by 2. Now you could set up division by a half, but then you'd end up taking the reciprocal and multiplying anyway. So we might as well just go right to multiplying by 2. And you'll see that this product is a 1 in a minute or so. Here's my other two inverses. I make sure that since my exponent was even, I have both my answers. I start with the original, multiply both by 2, and you see 2 times 1/2 is a factor of 1. I move up a row and divide both by g, and my g is reduced to a factor of 1, and then I take the square root of both expressions and simplify, and here are my two answers. Last, I want to check to make sure that I end up with the same expression, and I do, so I'm confident in my work. Here's the next one. Starting with a, I would add first, multiply second, and divide third. So here's my operations and inverses. Starting at the bottom of the right column, I'm going to multiply both by 2 and reduce those common factors of 2. I move up a row and divide by h. I reduce those common factors of h. I move up a row and subtract b. And here's my answer. To check my work, I return to the original, and instead of a, I'm going to substitute this expression right here. And after simplifying, I have a match, so I'm confident with my answer. Try this one. If r was a number, we would square first, multiply by pi over 3 second, and then by h third. Here's my operations and inverses. Please notice again that the idea is if I'm going to undo this factor of pi over 3, I can just multiply by 3 over pi. So I'll start here at the bottom of the right column. I'll divide both by h and reduce. And then I'm going to multiply both by 3 over pi. And then when I reduce, I'll get a factor of 1 times r squared. Of course, over here, I'll just have 3 times v and pi times h. Last, I'll take square root of both and simplify, making sure I include both answers. And here's my check. Try this one. I start by concentrating on the factor L sub 2. I have a multiplication and an addition. Multiplication would be first, addition would be second. Here are my inverses. I start with the original. I subtract L1, Q1 from both sides. Over on the right, these are unlike, so this is the best I can do. I move up a row, I divide both by Q2. Here on the right, I can reduce to 1. Here on the left, I just have a quotient. I have now solved for L2. Here's my answer, and here's my check. Here's one that you used earlier in the book. Now you can actually build the formula for yourself. Please solve for r. Looking at r, I would first multiply by t, then I'd find the power of e, and last I would multiply by p. So here are my operations. Here are my inverses. I start by dividing by p. I then take the natural log of both and simplify. I then divide by t and simplify, and here's my answer. There's a second way you can look at this answer, and that is to move this base of t up to the numerator with an exponent of -1. Both of these are fine. I think it's a little harder checking this one, so let me just spend a minute on that. Once I replace r with my expression, I end up right here with a product. But keep in mind that if I have a product and my bases match, I can add the exponents. So this is a -1, this is a +1 that we don't see. And if I add them, I get a 0, and then any non-zero base with an exponent of 0 can be replaced by 1. So I can replace this with 1, and then I undo my logarithm using the exponential. I reduce, and I match. How about here? Starting with x, I would square, multiply, add, and then take cube root. So here are my operations and inverses. First, I'll find the third power of both sides and simplify. I'll move up a row and subtract 1 and simplify. I'll move up a row and divide by 2 and simplify. And last, I'll take the square root of both and simplify, keeping in mind I should consider both my answers. Here's the check. Here's another. Starting from x, I would add, take natural log, multiply by a, and then add b. Here's my operations and inverses. I'll start with the original and subtract b and simplify. I'll move up a row and divide by a and simplify. I'll move up a row and make both expressions an exponent for a base of e and simplify. And last, I'll subtract k and simplify. This is my answer right here. I'm going to go back to the original and substitute that right here for x. And here's the check. Here's our last one. Concentrating on x, I would subtract first, square second, add third, and take square root last. So here's my table. I'll start at the bottom of the right column. I'll square both sides and simplify. I'll move up a row. I'll subtract y squared and simplify. I'll move up a row and take square root and simplify. I'll move up a row and add x1 and simplify. This is my answer. I've got a couple of them. And here's my check of one of the two. Well, that will conclude this video where we've continued solving literal equations.